Today we're going to talk about normal maps and blending normals together. Let's get started. Before we get too far into creating materials that blend normals together, I wanted to give a quick refresher on what a normal map is. I've got two normal maps here, and actually these are the same normal map, just that one is made for Unreal. This one here on the left is made for Unreal. And this one here on the right is made for Unity. And the difference is that the green channel is inverted. Let's take a look. So if I go over here to my channels and I pick the green channel, if we look at this one made for Unreal, you can see that it looks like the green channel is lit from the bottom. And if we take a look at this one made for Unity, you can see that it looks like the green channel is being lit from the top. The red channel on both of these is the same, as well as the blue channel. So if we take a look at the red and the blue channels, you can see that they match exactly, but the green channel is inverted. So in the one for Unreal, it looks like the channel is lit from the bottom, and in the one for Unity, it looks like the channel is made from the top. So when you're creating your normal maps, if you create one for Unity, make sure that it's set up lit from the top in the green channel, and for Unreal that it's set up lit from the bottom. That'll give you correct results in your normal maps for both engines. Getting back to what a normal map is, unlike a color texture, a diffuse texture, a normal map doesn't determine the color of the surface. It tells you what direction the surface is facing. You can see that kind of the overall color that we're getting here is kind of a light blue. And that color value is 0.5, 0.51 in RGB. And you can see that areas that are pointing straight up or that are flat are that 0.5, 0.51 in the texture. And areas that are not pointing straight up or flat are different colors depending on the direction that they're facing. So you can see that I've kind of got this green color pointing down, this purpley color pointing up, this bluish, darker bluish color pointing to the left, and maybe this orangey color pointing to the right. So the colors are not actually colors at all. They represent directional vectors that tell the material which direction each pixel is pointing. Now, if we have two normal maps, for example, if I have a rock and I have one normal map that determines the overall large shape of the rock, and then when I get closer to the rock, I want to see some tight detail when I get close up, I need to be able to blend the detail normal map, that tight close-up normal map, with the underlying normal map that controls the whole shape of the rock. That means I have to combine two normal maps together. And today what we're going to be doing is looking at 5 methods for combining our normal maps together. And I'm going to talk about the pros and cons of each of these methods. All right, so let's take a look in Unreal. All right, so here we are in Unreal, and you can see that I've brought in my cobblestones normal map that we were taking a look at Photoshop. And you can also see that I've brought in my texture coordinates, and I'm multiplying the texture coordinates by 2 in the U and 1 in the V, and that just kind of makes them look good on my preview sphere here. There's no reason that you have to do this, and you can multiply this by whatever you want. It doesn't really matter. What I do want to focus on here is that we're plugging our normal map into the normal socket of our root node here. And you can see that gives us some nice bumpy looking cobblestones on our preview sphere. So we just have one normal map at this point, and let's take a look at a couple of different methods for blending normal maps together. So this first method I'm just calling simple. I have my base normal map here at the top, and I'm taking the red and green channels of the normal map. And here I have my detail normal map at the bottom. You can see that my texture coordinates are being multiplied by 18 and 9, so I'm tiling this 18 times across the surface. So I'm taking the red and the green channel of the base normal map and the red and the green channel of the detail normal map, and I'm adding them together. Just the red and the green channels. I'm ignoring the Z channel or the blue channel for now. And then the last thing that I do is I append a 1. So for my Z channel, the third component of my normal, I'm just assigning it a hard-coded value of 1. Okay, so let's go ahead and plug this normal in and see what we get. So you can see that I've got my base normal here, and I'm also blending the detail normal, and that it's the same texture, it's the cobblestones. I'm just using that for an example, but you can see that it's tiled over and over here so that the detail cobblestones are small and then the base cobblestones are large. And you can see that these two normal maps are being blended together, but there is a bit of a problem with this method, and that is I lost some of the strength of my underlying normal map. If we come back here and I plug my original normal map back in, you can see that I have some nice strong normals here. But as soon as I plug in this method of blending these two normals together using this simple method, now my normals don't look quite as strong. They don't look quite as deep as they did before. And that's because I'm just appending this 1 here. So this method, it's not quite as good if I'm concerned about the quality of the normals. Now, if I do take a look at the stats here, let's compare the stats of not blending a normal together, or the base pass shader instructions. So you can see blending the normal together, I have 153 instructions. But if I just use the texture without any blending, it's also 153. So this is an extremely cheap method, just adding the red and the green channels together and then appending a 1. So this method is pretty much as cheap as you can get, but the problem is it does make the normals weaker. So if you want to maintain the strength of your base normal, in the example that I used where I was talking about the base normal map of the rock and then a detail normal map of the rock, you probably wouldn't want to use this method for that because it's going to make your base normal not as strong. So why would you want to use this method? What's this method good for? Well, if you have a bunch of normals to blend together, for example, on water, if you have a bunch of different water ripples to blend together, this is a good method for doing that. In fact, when I did my tutorials on rain ripples and also on water ripples, this is the method that I was using because it's the cheapest. And you can use it when you don't care quite as much about the normals being perfectly accurate. If you have a normal map that you've baked from a high resolution model down to a low res model and you're blending more normal map detail on top, you definitely don't want to use this simple blending method. Okay, let's switch over to Unity and take a look at the method there as well. All right, so here we are in Unity, and you can see that I've taken my same normal map, except this one has the green channel flipped. And here's my simple method. You can see that I'm using this swizzle node to access just the X and the Y of the normal, and then I'm adding them together, and then I'm combining them with a value of 1 for the Z component. And if I plug this into the normal on my master stack, now you can see that I have my detail normal blended together with my base normal. Now, I want to take a little bit of a sidetrack here and get distracted just a little bit to tell you about my favorite new node in Unity 2021.2. I'm running 2021.2 beta 8, which is a preview version of Unity, and there's this new swizzle node here that I really like the way that it works. I really like it because you can use it like the channel mask in Unreal. So here I've masked out the red and the green channels by typing XY in my mask. But it goes beyond Unreal's channel mask because I can also use this to swap the components. If I type YX, for example, now I've reversed and I put the green channel in the red channel slot and the red channel in the green channel slot. So I can reverse the components. I can also double up the components or duplicate them. So if I do XXY, for example, now I've copied the red channel into the green channel and then put the green channel into the blue channel. And so I can copy, I can rearrange, and I can mask out channels all with one node. And this new swizzle node is really powerful. I love it. Anyway, enough with the distractions. So that is the simple method for blending normals together, where you just add the X and the Y components together, and then you combine a hard-coded value of 1 for the Z component. All right, let's take a look at the next method. All right, so this method I'm calling UDN because it was first proposed on the Unreal Developer Network back in the Unreal Engine 3 days. And this is similar to this simple method that I'm using here. The only difference is that instead of appending a 1, we're just appending the Z component of the base normal map. So this is my base normal map here. And you can see that instead of putting a value of 1 like I did with simple, I'm using the value of the base normal map's Z component. And then I've also got this normalize here on the end. And what that's going to do is it's going to make the results more accurate. So let's wire this into the normal. And you can see if I compare this one, what I want you to see here is that these two normals, or these two methods of combining, the UDN method keeps more of the shape of the original normal. It's kind of hard to show you these because there's a little bit of a compile time in between. But hopefully you can see when I switch back and forth that this one is kind of soft and it removes some of the strength of the normals. But this UDN method is a little bit stronger and it keeps the strength of the underlying normals the way that they were. Now, if we look at our instruction count down here, you can see that the UDN method costs 159 instructions, whereas the simple method only costs 153. So there's a significant reduction in instructions for simple, but you do give up some quality. So UDN is pretty usable. What you do give up, though, is the quality on the detail normal map. Because I'm not using the Z channel of the detail normal map, I'm just skipping that and only using the X and Y. The quality of the detail normal map is reduced for UDN. And if we take a look at Unity here is the UDN method in Unity. You can see that I'm taking the X and the Y of the base normal map and the detail normal map, adding them together, and then I'm combining that with the Z component of the base normal map and then normalizing at the end. And if I wire this into my master stack, now you can see, I don't know if you can see that, but we got a lot more detail around the edges of the base normal map. Let's take a look again. Let's switch back and forth. So here's our simple, and here is our UDN. So our normals are a little bit higher quality in UDN. All right, let's take a look at our next method. And this method is called Whiteout, and it was first introduced by Chris Oat in the AMD, or maybe it was actually back in the ATI days when they made the Ruby Whiteout demo. And this was a method that Chris introduced for getting even better quality combining normal maps. It's fairly similar to the UDN method, except the way that we handle the Z channel of the two normal maps is we actually multiply them together. So I'm adding the red and the green channels together, and then for the blue channel, or the Z component of the normal, I'm multiplying them, and then I append that together, and then I normalize. All right, so let's take a look at the results here. And I'm just going to switch back and forth really fast. So here is UDN, and here is Whiteout. I don't know if you can see that, but the detail normals are a little bit stronger now because we're actually using the Z component of the detail normal here to improve our results. Now, again, if we take a look at our instructions, now the Whiteout is taking 164 instructions, where the UDN method is taking 159. So we're paying 5 more instructions, but we are getting better quality. So here we have the Whiteout method and the UDN method. So each of these methods that I'm showing is progressively better quality, but a little bit more expensive. So you have to decide where you want your trade-off between expense and quality. If you're doing a character and you want really nice quality on the character and you know the camera is going to be getting really close up, you may want to use whiteout instead of UDN because you'll get better quality on the combination of the base normals and the detail normals. All right, and we'll switch over to Unity. So here's the whiteout method implemented in Unity. You can see again, we're taking our base normal map, the X and the Y, and the base normal map, the detail normal map, X and Y, and adding those together. But then we're taking the Z component of both normal maps and multiplying them. And then we combine the X and the Y with the multiplied Z's before we normalize. And then let's pass this one into the normal component of our master stack. And we get some improved quality in our blending. All right, let's take a look at one last method. And this method we're calling RNM. And the RNM method was originally proposed by Colin Boisbois and Stephen Hill. And this method is a little bit more complicated, but it's also the most accurate. So here I have my base normal map, my detail normal map, and I take the red and the green channel, and for the Z or the blue channel, I'm adding 1 to that, and then appending those back together. So basically, I've just added 1 to the Z channel or the Z component of my base normal. And then for my detail normal, I'm multiplying red and green by -1 and appending that back together. So I've got red and green multiplied by -1 here, and my Z channel here with 1 added. Then I do a dot product between those two, and I multiply the result by the original vector that I created here. And then for the detail normal, I multiply the vector that I've created here by the Z component with 1 added. And then I subtract this vector from this vector, and I get my result. Now, if you want to dive deep into the math on how this is all working, I'll put a link in the description to what this RNM blend mode is doing. I'm not going to get into it now because it's fairly complicated, but if you want to read up on all the math formulas and how this works, that's great. You can check that out in the link in the description. All right, so I'm going to wire this into my normal socket, and we'll take a look at our result. I'll switch back and forth between whiteout and the RNM method. And I don't know if you can see it, but there's a little bit more detail, especially in the detail normals in the RNM method. Now, if we do look at our instruction count, this method is also 164 instructions here, and whiteout is 164. So we haven't increased our instruction count with the RNM method, but we have increased our quality, and that's fantastic. All right, let's switch over to Unity. And here we have the Unity or the RNM method implemented in Unity. So we have our detail or our base normal and our detail normal. We're doing the same thing here where we add 1 to the Z and bring it back together. And we multiply the X and the Y of our detail normal by a -1 and bring it back together. Then we do the dot product, multiply by the original vector, and here we multiply by the Z component of the base normal added to 1, and then we subtract this vector from this vector, and then we need to wire that one in. And we get some even further improvements on our normal map blending. Pretty cool. Okay, let me show you something else that's important. Unity ships with this node called Normal Blend, and there are 2 different methods that it uses for blending normals. There's the default method, and there's the reoriented method. And if you're wondering what those are, the default method it's using is the whiteout method. Okay, so by default, we're going to be using the whiteout method with the built-in normal blend node. And if you pick reoriented, you're going to be using the RNM method of normal blending. So this normal blend uses whiteout by default, or you can pick to use RNM if you prefer that. And if we switch over to Unreal, you can see that Unreal comes with this node called Blend Angle Corrected Normals. This node is meant for blending normals together. You can see there's an input for base normal and another input for additional normal. And this node here does RNM normal map blending. So if you want to do the highest quality normal blending, you can use Blend Angle Corrected Normals to use this RNM method. Or you can do any of these other methods just by setting up the nodes that I've set up here for Whiteout, for UDN, or for Simple. All right, so that's the built-in node in Unreal, and also the built-in node in Unity for normal blending. I hope this tutorial has been helpful for you. I hope you can see that there are a whole bunch of different ways of blending normals together. We can't just use regular overlay methods or the methods that we would typically use for blending colors together, because these aren't colors, they're actually vectors or directions. So we have to be careful with how we do this. But you can see there's a bunch of different ways to do it, ranging from this simple method all the way down to the RNM method, where there are trade-offs between quality and performance. So I hope this has been helpful in showing you the results that you can get and the relative expense between the different methods. So again, you want to use the simple method in areas where you don't really care how high your quality is. You just want to do some normal blending that's as cheap as you can make it. And then progressively, there's UDN, which is a little bit better, but still pretty cheap. And then Whiteout and RNM that are as high quality as you can get, but a little bit more expensive. Okay, that's our tutorial for today. I hope you enjoyed it, and I do want to give you guys another choice. So last week I talked about doing normal blending versus smooth step, and it was pretty close, but I think more of you asked for normal blending, which is why we're talking about that today. So next week we could talk about smooth step, or I could get into I could go into some more detail on methods for using these normal blending techniques for doing detail normal mapping on rocks, as well as detail normal mapping on cloth. So let me know in the comments if you want more details on detail normal mapping, or if you want to do smooth step like we talked about last week. Anyway, that wraps it up for today. Have a great week, everybody, and we'll see you in the next video.